In this video, we'll be looking at an expression for escape speed. So first of all, what is escape speed? Well, if you throw a projectile upward, it will rise and slow to a momentary stop and then fall back down. There is, however, a certain minimal speed where the projectile will continue to move upward, reaching that momentary stop only at infinity. The speed that we would have to throw the projectile for that to happen is called escape speed. The idea behind this expression is going to come from using UK, or gravitational potential energy to start plus kinetic energy to start is equal to gravitational potential energy to end plus kinetic energy to end. Everything on the left-hand side deals with our object that's trying to establish this escape speed at the surface of a planet. Everything on the right-hand side will be everything dealing with the object when it is at infinity. Take a moment to think about what the expressions for U and K might be on each side of this expression. Okay, so on the left-hand side, the gravitational potential energy is found by using the expression that we developed earlier, negative G, big M, little m, over R. The initial kinetic energy is 1/2 little m times speed squared, where this speed is the escape speed. Everything on the right-hand side, remember, deals with the object when it's at infinity. At infinity, the gravitational potential energy is 0, the way we defined it when we spoke about gravitational potential energy in developing the formula negative G mm over R. And as I just described, the way escape speed is described is the object reaches that momentary stop only at infinity, which means if it's stopped, the kinetic energy is 0 out at infinity as well. So at this point, all we have to do is rearrange our expression solving for v sub 0, which would be our escape speed. So adding the gravitational potential energy over to the right-hand side gives us 1/2 mv initial squared equals g, big M, little m, over R. You can see here that the mass of the object that is escaping doesn't matter. Simplifying a little bit further, we get the escape speed squared is equal to 2g big M over R, or the escape speed is equal to the square root of 2gm over R, where m is the mass of the planet you're trying to escape, and R is the radius of the planet you're trying to escape from. And there you have it, an expression for escape speed.